Hi, my name is Prebah and I'm a teacher teaching science for 20 years. In this channel, you are going to learn the secrets to the theory and to understand the magnetic effect of a current carrying conductor, part 1. When you subscribe to my channel, you are going to learn more videos about electromagnet and you are going to get great confidence to answer science questions. In today's lesson, we are going to learn what is electromagnet and understand magnetic field due to the current in a straight wire, circular coil and solenoid. Every single week, I will upload one video. If this is the first time you are visiting my channel, make sure you hit the subscribe button below and click on the bell and turn on the notification. Hello everyone, welcome to my Science Buddy channel. My name is R.Prebasubah and today we will be learning part 1, magnetic effect on current carrying conductor. Let's learn how to define electromagnet. Electromagnet is a device that acts as a temporary magnet when a current flows in the wire. The key word here is temporary magnet when current flows in the wire. Let's look at this illustration. Here we have a battery and a wire that acts as a current carrying conductor. Now the wire is coiled around a nail. So what happens here is, when there is a battery, a magnetic effect or magnetic field lines is created around the nail. So here the note says, the nail has the character of a magnet when current flows in the wire. Let's simplify this. When there is a current flow, magnetic field lines are created. The nail is magnetized and temporary magnet is created, which attracts the pin. Now, this is what these notes actually represent what is happening in this illustration. So, let's see what happens when electric current flow is switched off. Let's use these simplified notes to explain. When there is no current flow, the magnetic field lines disappear and demagnetize immediately, which makes the pin drop down to one end of the nail. So what happens here is, when there is a battery, the nail is magnetized, whereby a magnetic field line is created, which makes the pin attract to one end of the nail. But when the battery is disconnected, what happens here is, this magnetic field line disappears, which makes the pin drop down due to the demagnetization that occurs. So, what we can conclude here is, when there is no current flow, the magnetism of the coiled wire is lost immediately, which makes the pin not attracted anymore. Next, we will learn in detail the magnetic field lines in a straight wire, circular coiled wire and solenoid. Let's start off with a straight wire. A wire carrying a current is passed through the center of a manila card. Few small compasses are placed around the wire to indicate the direction of the field. Notice that when there is no current flow, the direction of the compass needles are pointing towards the North Pole. When there is no magnetic field lines around the wire, no current flow, and all the compasses are pointing towards the north. And finally, when there is a current flow, this is what happens. As soon as the current flows upward in the conductor, there is a change in the deflection of the compass arrows. The arrow forms a pattern of circle around the wire. Now, how would we know which direction does this compass supposed to move? Whether it's clockwise or anti-clockwise. Now let's get excited now. This is where we are going to learn right hand grip rule, which will help us to find out the direction, whether it's clockwise or anti-clockwise. In this illustration, it shows the right hand grip rule. It starts by placing our thumb in the direction of the current. Then we grip the wire using the right hand. Our fingers now point around the wire in the direction of the magnetic field. Let me show you how it's done. First, we place our thumb, same as the current flow, which it moves upward. Therefore, my thumb actually is pointing upward. Then make sure your fingers are in this position and curl them around the wire. When you are curling, did you realize that the movement of my fingers are from back to front? This motion from back to front is the one that shows how it's moved around the wire. When it goes from back to front, and this is how it is circled. Therefore, the compass shows in this direction. And finally, what we can conclude here is that the compass are in anti-clockwise. Now, what happens when the direction of the current is reversed? Let's find out. Here, same situation is as before. We have a straight conductor wire passing through a cardboard. But this time we are going to understand what happens when current flows downward. On top of the cardboard, we are placing compass around the wire. This is to determine the direction of the magnetic field lines created around the wire. But as soon as the current flows down in the conductor, there is a change in the deflection of the compass arrows. It goes in a circular motion in clockwise direction. Now, how do we know which direction does this compass arrow moves? Let's use right hand grip rule. Our right hand thumb points downwards. This is because we are following the direction of the current flow. The other four curled fingers point to the direction of its magnetic field. Now let's get back to the diagram. Therefore, here you can see that the current is flowing downwards. I will place my thumb downwards, then making sure that all my four fingers are straight. Later, make sure you curl around the wire. You realize that the motion of the curl starts from here going backward. That's what happens here. Therefore, the motion of my curling goes from front to back. That's why, and that's how we determine the direction of the magnetic field line. Here, it acts in a clockwise direction. Next, we will learn how to draw cross and dot based on the direction of current coming out and going into the plain paper. In this part, we are going to learn dot and cross. But before that, I have a simple way to make you understand which correct motion illustrates dot and cross. I would like you to imagine an arrow's movement and placing your eyes at the front and back of the arrow. At the front of an arrow, we will realize the arrow is moving towards our eyes. And we can observe the tip or the front part of an arrow. Therefore, this comes as a dot for current flow. At the back of an arrow, we realize the arrow is moving away from our eyes, and we can observe the cross or the feather part of the arrow. This is illustrated as cross for current flow. Now let's make it more clearer for you. Here is two illustration where our eyes are at the top view of a manila card. Here, our eyes, and same goes here. In the first picture, we can see that the current flows moving away direction from the eye view. Therefore, when the arrow is moving away, we can only see the back view of an arrow, that is cross. Here you can see the cross. Therefore, we draw a cross to show the direction of the current flow. Next, we can see the current flow towards the direction of the eye view. Therefore, when the arrow is moving towards our eye here, we can only see the front view of an arrow, that is small pointy arrow. Therefore, we draw a dot to show the direction of the current flow. Here, I'll just place it to show that how it looks like, the dot. Now we have learned the dot and cross. Let's apply them using right hand grip rule. In the first diagram, the cross shows that the current is going into the plain paper. The thumb is pointing in the direction of the current, which is into the paper. And as you can see, straight, and when I curl up, it goes from top to bottom. Your other fingers now goes around in the direction of the magnetic field, and this shows clockwise direction. Thus, we draw the direction of the compass as clockwise direction, as illustrated using these red lines. In the second diagram here, the dot shows that the current is coming out of the plain paper. The thumb is pointing in the direction of the current, which is out of the paper. Therefore, I will place my thumb coming out of the paper in this direction. So when I am curling up, can you see that the direction of the curl of my four fingers is in this way, which goes like anti-clockwise. So your other fingers now goes around in the direction of the magnetic field, and this shows anti-clockwise direction. Thus we draw the direction of compass as anti-clockwise direction. So I'm just going to place this, and you can see that this goes in an anti-clockwise direction. Alright, so next we are going to learn circular coil. Here you can see two straight wires, one carrying current upward and the other downward. Here is a drawing that shows the top view of a circular coil. One is where the wire comes out of the paper, which is illustrated as a dot here, and another is where the wire goes into the paper, which is illustrated as cross here. Now I'm going to show you what happens to these magnetic field lines in between these two wires. It is illustrated in these two diagrams in here. In the center of the coil, the field pattern are in same direction, and due to this two parallel magnetic field lines, it produces a strong combined field. It's right over here. Therefore, the strength of the magnetic field lines can be represented by the number of lines drawn and how close they are drawn. It's right over here. We can see that the number of lines drawn here are more, and similar same in here. The more lines drawn, therefore, the stronger combined magnetic field exists. Next, we will learn magnetic effect on solenoid. A solenoid is a long coil made up of several turns of wire like a cylinder. When a current flows through the solenoid, the pattern of a magnetic field is identical to a bar magnet. Here is the magnetic field that is created from the solenoid. Now, at the end of the solenoid, two opposing magnetic poles are formed. But how are we to determine the polarity? Right? So here's a simple notes for us to understand how to determine the polarity. Now, the polarity at the end of the solenoid can be determined by looking at the end of the solenoid. So I'm going to place here how we are observing from this end, one, and an eye view from this end. So looking at the end of the solenoid, and that is where we determine north pole and south pole based on the direction of the current flow at the end of the solenoid. And number two, using the right hand grip rule. First, I'm going to teach you how to determine the direction of north pole and south pole. In here, I would like to teach you how to draw the word. By drawing it correctly, we can determine the direction of north and south pole. Let's start off for north pole. The way I draw for north here, I will start my pen here, going upward as usual. But when I come to the third part of the stroke, I would turn in this way and I will draw an arrow. Therefore, the N, which represents the north pole, the third stroke in here, I would draw an arrow which indicates the end of the N here as a direction that flows in an anti-clockwise direction. Same thing applies for south. Now for south pole, I will place my pen here, start drawing, but towards the end part of it, I will draw an arrow. This indication, the arrow indication, actually shows the direction of the flow. Therefore, if you can see, it goes in a clockwise direction. So for north, it goes as an anti-clockwise, while for south, the rotation goes in a clockwise direction. Now, why are we learning this? Is because we want to see how the current flows. If the current is flowing in a from how I would say from right to left, therefore in an upward direction, it goes in an anti-clockwise. But if the current flows from left to right, in the upward direction, it goes in a clockwise direction. Therefore, that polarity there is south. Now, what we do is, let's go back and see how we can utilize this knowledge in the solenoid. At the end of A, we can say that the current flows from bottom to top. Let's go and see the diagram. This is where our battery, and the current flows out of the battery, and if you see carefully, it goes from bottom to top. But when we view from here, we realize that our eyes, which is facing in this direction, we see that the current from bottom to top, which moves from right to left in an upward direction. This motion actually represents an anti-clockwise direction. If we remember carefully, an anti-clockwise direction represents the north polarity. So therefore, A represents the north polarity. But let's look at what we can view from B. We can see that the current which flows in this direction finally comes in from here to this side, from bottom to top. But when we view it this way, which is in this direction, let's see, from bottom to top. So what I can see from this angle is from left to right hand side in upward direction, which represents a clockwise direction. Therefore, a clockwise direction is represented by south polarity. So I can say that when I view it from A is north, while when I view it from B it is south. We also must understand that the two ends of the solenoid is two opposing magnetic poles. So far we have learned how to determine polarity by looking at the end of the solenoid. Next we will learn by using right hand grip rule. And finally, I would like to introduce right hand grip rule, where by using your fingers around the solenoid, the direction of the thumb will show the north pole. You can observe from this illustration that the direction of the current flow must be matched with the direction of the fingers curling back to the palm. Now as you can see, since the current flows from bottom to top in this way, therefore even the fingers curl in upward direction. By doing so, the thumb actually is pointed in this way, which shows and confirms that this end is a north pole. So by doing this action, the polarity of one end of the solenoid can be obtained by looking at the thumb direction. The thumb will point to the end, that is north pole. Well, we have finally come to an end of part 1. In my next lesson, part 2, we will be learning factors that affect the strength of electromagnet and application of electromagnets such as electric bell, telephone receiver, circuit breaker and lifting magnet. If you like my video, don't forget to subscribe, comment and like. Thank you for watching.